Hello everyone! Today we'll be presenting TeraStruct, an automated resource tracking and allocation system designed for road construction projects. Our focus is on a Python program that models and manages the materials required in road building. The main purpose of this project is to help construction managers efficiently estimate the quantities, weight, and cost of necessary materials like asphalt, gravel, concrete, steel, aggregates, and soil. By automating these calculations, TeraStruct reduces human error and streamlines planning and budgeting for road projects.
In this presentation, I will walk you through to a Python-based road construction management system. This system estimates required materials, their weight, and total cost for a given road construction project based on user input.
We begin by defining a class called material. This class holds the common attributes like name and cost per cubic meter and provides a method to compute cost from volume. This class is base class that other material types will inherit from and simplifies cost calculation across all material types. We now define individual material classes like asphalt, gravel, concrete, sand, and soil. Each has known density and includes a method to calculate.
Each subclass inherits the cost method from the base class, but adds its unique density and a weight calculation method.
This class is based on the offer materials types will inherit from its simplifies cost calculations across all materials type. We now define the individual materials classes like asphalt, rubbles, concrete, soil, and sand. Each has known density and calculate weight. Each subclass inherit the cost method from the base class but adds its unique density and weight calculation method.
Next, we define our road class to handle the road's dimension and estimate how much material is needed. This is the core logic that breaks down the road volume into different material layers and calculates the total cost and weight for each.
We assume the road has layered construction and split the total volume proportionally. Then we will collect the cost input from the user and initialize the material objects.
The final section runs the program by asking the user for road size and calling the material estimation. Once the user enters the dimensions, the program runs all calculations and prints out the material summary.
In this part of the program, we introduce a cart system which plays a crucial role in managing the different construction materials before the final cost estimation is performed. The cart acts as temporary collection list where users can input materials intended to use along with their corresponding cost per cubic meter. This feature allows flexibility, letting users modify material detail as needed based on project requirements or budget constraints.
First, users are presented with an option to add a new material to cart. When they choose this option, the program prompts them to enter the name of the material, for example, asphalt, gravel, or bitumen, and then ask for the cost per cubic meter. Once the information is entered, the material is stored to a Python dictionary called cart, with the material name as the key and the material cost as the value. This enables the program to quickly look up and reference any materials added to the cart.
Next, if a user realizes they entered an incorrect cost or wants to update the pricing information due to supplier changes, they can select the Edit Material option. When this is selected, the system asks which material the user wants to modify. If that material exists in the cart, the user can then enter a new cost value and the program automatically update the existing entry. This ensures that all material data is accurate before calculating the total project cost.
Similarly, if the material is added by mistake, it's no longer needed in the project. The user can make use of the deleted materials option. In this case, the program also asks for the name of the materials to be removed. If the name of matches an entry in the cart, that materials and its associated costs are deleted from the dictionary, ensuring the cart only contains the relevant and confirmed items.
To help users keep track of what has been entered, there is also a view cart option, which simply loops through the dictionary and prints out all the cart material names and their costs. This gives the user a clear overview before proceeding to the final estimations.
Once all desired materials are added and reviewed, the user can choose to estimate cost option, which ends the cart editing process and proceeds to the calculation of total material volumes, weights, and final costs using the information currently stored in the cart. This flexible and user-controlled system ensures that every material used in the project is accounted for correctly and based on updated input from the user.
In conclusion, this Python program helps us estimate the required construction materials, their weights, and the total cost for building a road. By using object-oriented programming and user inputs, the system offers a fast and practical tool for engineers and planners to manage resources and budget effectively.